the triangles we've been looking at so far have been in quadrant 1. We want to start drawing triangles in the other quadrants as well. So let's look at question 1 here. Draw a right triangle of 30 degrees in quadrant 2. So we remember that quadrant 1 is here, and then quadrant 2 is the other quadrant on top. We're going to start at the origin again and put our 90 degrees on the x-axis. If you had forgotten that, please make note of it with your red pen or highlighter. Now I'm asking us to find positive theta and negative theta. Remember that this is where we start on the positive x-axis. This is always 0 degrees here. Positive theta moves in this direction. Negative theta in the other direction. Both of them stop on the terminal side. Notice that the terminal side is the hypotenuse or the radius of our triangle. Positive theta. Well, let's think about this. We drew a 30-degree triangle, so we know that this is 30 degrees here. We also know if we went all the way to the negative x-axis, we would be at 180 degrees. So our positive theta is 30 degrees less than 180, 150 degrees. Our negative theta is 180 degrees plus 30, 210 degrees in a negative direction. Notice that if we find the absolute value of 150 degrees plus the absolute value of 210 degrees, it should always equal 360 degrees, because together, positive theta and negative theta form an entire revolution. 30 degrees, that angle inside the triangle, is known as the reference angle. Let's try another triangle. So in question 2, we're drawing a 60-degree triangle in quadrant 3. Start at the origin, 90 degrees on the x-axis. This is our 60-degree triangle here. Again, we want to find positive theta and negative theta. Starting on the initial side in a positive direction, we see our positive theta, and in a negative direction. So what is our value for positive theta? We see that till the x-axis is 180 degrees, but then we've gone 60 degrees further. This is 180 plus 60, or 240 degrees in a positive direction. If we look at negative theta, we see that it did not go all the way to 180. It was 60 degrees less. 60 degrees less than 180 is 120 degrees in a negative direction. This time, 60 degrees, that angle inside the triangle, is our reference angle. Now we're in quadrant 4. We're going to draw a 45-degree triangle. And again, we're going to start at the origin. And our 90 degrees is on the x-axis. Here's our 45-degree angle inside the triangle. We want to find our positive value theta. So we're again starting here positive theta, negative theta. Positive theta we see is 45 degrees less than 360 degrees. 315 degrees. Negative theta is just that 45 degrees, but because we're talking about theta, not the angle inside the triangle, it's a negative 45. Positive 45, the angle inside our triangle, is our reference angle. Using the reference angle is going to help us find our trig ratios when theta is greater than 90. And remember that the reference angle is always measured between the x-axis and the hypotenuse. That's going to be important when, instead of giving you the reference angle, I give you theta. Take some time to look over these triangles. Get used to finding positive and negative theta for each of them.